So all real numbers except 2. And let's pick another color. Okay, all real numbers except 2. In interval notation, we would say from negative infinity to 2, exclusive, and then again from exclusively 2 to infinity. You guys are right with interval notation? That means everything but 2. Okay? What's the domain here? All real numbers. I like it. So we'll write that in interval notation from negative infinity to infinity. Why do we know it's all real numbers, guys? Because there's no what in the denominator? There's no variable. Awesome. Find the domain of this rational expression. What do I need to do here? Factor. Okay. Okay, so we'll go x minus 5, x plus 3. So x can't be what two values? X can't be 5 and negative 3. And if we wrote it in interval notation, we would say from negative infinity to negative 5, exclusive, from negative 5 to 3, exclusive, and then from 3 to infinity. Did I mess up? Yeah. Did I mess those up? Why did you guys not stop me a minute ago? You guys are worried about my feelings. I appreciate that. How about 5 and negative 3? So let's erase all this. Erase all that garbage. All right, here we go. Let's try it again. From negative infinity to negative 3, from negative 3 to 5, and from 5 to infinity. How about that? Is that better? It'd be a lot easier to just say all x values except negative 3 and 5. Would you agree? Okay. All right, now I'm asking you to simplify this rational expression. So I'm banking on this being really easy for you guys because you guys are really good at factoring. That the denominator is going to factor into what? X plus 2 and x minus 2. And in the numerator, I have two binomials of x plus 2. So I could cancel one of those x plus 2's out of the numerator and the denominator. And my simplified rational expression would be what? X plus 2 over x minus 2. Okay, everybody circle that answer. Put your pens down. Okay. Don't be the ding-dong that does this. So don't do this. Well, I'm going to cancel out those x's. And then 2 divided by negative 2 is negative 1. Don't do that. Remember, think about this. This is a term. This is, if you will, this has that meaning, right? They're held together, so you can't be canceling between plus and minus, only when it's times. Are we okay with that? All right, you can pick your pencils back up now. Okay? So this one, I have a monomial, 1 term, over a binomial, 2 terms. Okay? So what do they all have in them? 2x squared. So if you will, if you factored out that 2x squared in the denominator, you're left with what? 5x minus 1. So when I cancel the 2x squareds, what's my simplified rational expression become? 1 over, thank you, Minachi, 5x minus 1. There we go. Circle that answer. We good? All right. Okay. What do you want to factor? The denominator will factor real quick, won't it? Into x plus 3, x minus 2. Agree? What can you do in the numerator? Oh, more than a 5. Negative 5. Yeah, let's see what where that leads us. If I factor out a negative 5, that becomes positive x squared. And then that becomes what? Negative 4? Why do I like that? We can continue factoring, can't we? That becomes what? X plus 2, X minus 2. So what can I factor out? What terms can I factor out both the numerator and denominator? Just a what? Just an X minus 2? So then we're left with in our numerator negative 5 times X plus 2. And in our denominator, X plus 3. Nice. So this would be not a fun section if you weren't good at factoring. But good thing for you guys, you're all like professional factors. Okay? With the person you're sitting beside. See, you guys coach me up real quick. You soaked it, right? So you had an X plus 4 in the top, which cancels, and then you were left with what? X squared minus 4X plus 16? Nice. Okay. All right. What can I factor out of the numerator? Okay, so I factor out a 5, and I'm left with 5 times z squared plus 2. Good. What can I do to the denominator? Factor by grouping. Z squared, so I'm left with z minus 3, plus factor out a 2, z minus 3. That's good, because then I can factor out a z minus 3, and I'm left with z squared plus 2. All right. Those z squared plus 2's cancel, don't they? So then I'm left with 5 over z minus 3. Questions? So, stop right now. Is this easy?
Yes.
Awesome.
I have a question.
Gosh darn it. Taylor, what?
Wait, I thought we had to put the answer in interval notation, but you just left it like 5. We're just simplifying.
We're just.
Oh, we're not finding. Okay.
Hey, somebody. All right. Somebody give her a filter. You got to go through. Is that true? No. We just talked about this. You can't do that, can you? Yeah, I didn't ask find a value of n that makes this expression equal to 1/2. I understand 2 would make equal 1/2, right?
Yeah.
I'm asking, does this equal this? And the answer is no. You don't make. I'm trying to emphasize again. Don't be a ding dong and do that. Okay? All right. Why am I trying to trick you? All right. So now I have a rational expression times a rational expression. No worries. Watch, we're going to do something really crazy here. We're going to just go ahead and make this one long bar. Oh my goodness. Things are getting crazy. And then we're going to look and see, what can I factor? Can I factor 2 plus 5n? No. Can I factor 6n plus 3? Yes, factor out of 3. 2n plus 1. Okay. Can I factor out 3n? No. Can I factor 5n squared minus 3n minus 2? Maybe. Let's see. So what? 5n and n and then minus 1 plus 2. Okay. Now we look and see what can I simplify out? Well, I can cancel out this binomial and this one. Would you agree? So we cancel out the 2 plus 5n's. What else can I cancel out? Oh, Taylor, good job. All right, the 3's. Because this is a monomial. So you can take out that 3. Y'all seeing it? So what am I left with in my numerator then? 2n plus 1 over, what am I left with in my denominator? N times n minus 1. You do not have to multiply this back through. Just leave it factored out. Yeah, okay. Dylan, why are you the one asking that? That sounds like a Taylor question. Okay? I did record that.
Being attacked.
I'm sorry, there's an app over there, Taylor.
I think I might need to scan it after this last meeting.
Okay. You guys want to try this one on your own? Here, I'll help you out. I'll help you out at the beginning. Ready? There, I made one bar for you. Okay, I got your backs. You can coach me hard too. I'm not delicate. You can give me crap. All right, so x minus 2, x squared plus 2x plus 4. How am I doing? 6x squared. I'm going to take out a negative 6 to get x minus 2. That way I can cancel that, right? And then x plus 2. Wait a minute. No, forget that. How about right here, x squared plus 2x plus 4 right now? Boom, boom. And then boom, boom. Woo! Negative x squared. Feeling good? All right. What are you going to do?
Flip it.
Okay, let's flip it. So let's go 6y cubed, maybe. All right, so 6y cubed over, what can I factor out of the denominator on this bottom left, if you will? Factor out a 3. Let's do it 2 steps in our head. If you factor out a 3, this would be a 9, wouldn't it? And that would be y squared minus 9. So how about 3, y plus 3, y minus 3? You're going, nope, Mr. Dice, I got to write that in 2 steps. Okay, go ahead. Come on. That's cool. That's cool. Again, because look, I'll put it right here for you. Y squared minus 9. See it? Okay, so this 42 is coming down here. Agree? And what do you want to do with that 3 minus y? Factor out a negative, because now it becomes y minus 3. What?
Why is there a negative by 6y cubed?
Did I just not say? Jacob?
She did not consult me.
Taylor?
She did not
Oh,
consult
it's
the
part of the
council.
loop. It's part of the loop.
Taylor, go through the filter. Because 3 minus y, if you took out the negative, doesn't that make this positive y?
No, I was talking
And
about the 6y cubed because, like, the little loop, I thought it was a negative, but I was just being like,
Now, are you all good with this negative being taken out? So then we can cancel out these. What else?
3 and 6.
Okay. Can I do this? I'm going to be more efficient. How about the 6 and the 42? I could make that a 1 and make that a 7. Okay, what am I left with in my numerator then? Negative y cubed. Way to not forget about the negative. And what's in my denominator? Whoa, where's 21 coming from? Oh, the 3 times the 7. Okay. 21 times y plus 3. Are we okay? So far. I think that's about it. Okay. Well, so all you're going to do, look up here. All you're going to do is factor. All you're going to do is factor. All you're going to do over here is flip factor, right? Okay, so I'm going to let you 5x minus 1 and x minus 10. Okay? So I'm going to take the top right or bottom right and put it in the top right. Everybody with me on that? So take that 7x squared. Duffy, what's that factor into? Go.
7x plus 2, x minus 10.
7x plus 2 and x minus 10. And that top right, Jacob, filter, Thornton, what do you get?
For the bottom right?
Well, the only one left.
Yes. 2x plus 5 and then x plus
X plus what?
2.
Everybody agree on everything?
Yeah.
Man, that works out nice. What? Anything cancel? 2x plus 5s. 5x minus 1. It's really satisfying to cancel all this out. X minus 10s. And you're left with 7x plus 2 over x plus 2. Wait a minute. Wait a minute.
No.
Oh, no. Okay, you can't do that, can you? Okay.
I thought he was going to do that. I was like, dang it.
I scared you? No. Wait, what? Okay. I looked at him, he backed down. It's all right. Okay, let's do it together. Top left, x squared minus 16 factors into x plus 4, x minus 4. Let's continue on. Let's just keep rolling along at the top. The 5x minus 20 factors into 5x minus 4. What am I going to put right there to the right of the 5 times x minus 4? X. Nice. Okay, let's go bottom left now. Let's just write that x minus 4 squared as x minus 4, x minus 4. And then 3x. And then we're going to take this x squared plus x minus 12. We're going to factor it, and it factors into x plus 4, x minus 3. You guys all agree with me?
Yeah.
Okay, let's start canceling. Okay, now careful. You can only take one x minus 4 for each one. Then I can go here for the other one. Okay? X plus 4. Oh my goodness. And the x's cancel. Is that it?
Yeah.
5 over 3 times x minus 3.